when two identical waves add together to make an even larger wave. And the example for this is concert speakers. If you've ever been to a concert before, you will know that they have lots and lots and lots and lots and lots and lots of speakers. Because you want it to be loud, okay? You didn't go to a concert for it to be quiet. You went to a concert for it to be loud. So, why do they have so many speakers? They have so many speakers because of this, constructive interference. If those speakers are all playing the same sound, those sounds will overlap and make an even larger sound than they would before. So instead of having to crank your speakers up to 11, you can just have your speakers loud, and they will add together to make it even louder than it would before. That's why there's so many, and that's why they're on opposite sides of the room. Not because these speakers are for the people on the right and these speakers for the people on the left. It's because they add together to make an even larger sound than it would normally. And that is the idea of constructive interference. But the destructive one you're actually more familiar with. That's when two opposite waves add together to cancel out or make a smaller wave. Okay? And this is noise-canceling headphones. So how do noise-canceling headphones work? Here's how they were originally designed. They were originally designed for people flying in airplanes. Okay? They were originally designed for people who traveled all the time on airplanes. So what did they do? They went in and they figured out what was the frequency of all of the sounds you hear on an airplane. The engine noise, the vibration of the fuselage, the air coming through, the person snoring next to you, the little kid screaming in the back passenger area. That's what they figured out. Alex, can you put the phone up for me? Thanks. So they were trying to figure out what all the sounds were. And then they made the exact opposite sound. And they put it in the headphones. And so, when the opposite sound hits the actual sound in your ear, they cancel out, they subtract, they add together to make a smaller wave, and you don't hear that noise. If you've ever tried out like the really expensive ones, like the really, really swanky ones, like Bose and those kind of things, like the over-ear, like monstrous ones, it's like you can't hear anything at all, like the very specific noises. They have some demos sometimes at places like Best Buy and those kind of places where they will put the they'll set up like a speakers, you put them on, and it's talking to you about how great the speakers are and everything. And then all of a sudden they're like, hey, take them off. And you take them off, and there's this huge noise racket going on in the background that you couldn't hear. And that's because they're very specific on canceling out those specific sounds. And so that's how noise-canceling headphones work. If you've ever listened to noise-canceling headphones in a quiet room, they make noise, right? They make noise. The reason you don't notice that in a loud room or outside or wherever you are is because those noises are canceling out with the noise around you. But in a quiet room where there's no noise being produced, you don't hear that noise and it won't cancel out. It's just the noise that you're hearing that it's producing. Okay, any questions for me about either of those two things? All right. Sweet. All right, last one here on this page, and then we'll jump to notes 2. All right, beats. Explain what beats are and what causes them. So beats are actually easier for me to show you than to try to explain first. So let me show them to you first.
Let me get these things so they're a little bit different in frequency and strike them both at the same time.
So they're not the same anymore. They're just slightly off. They're not opposites. They're just slightly different from each other.
Can you hear the throbbing? That is the result of interference, and the phenomenon is called beats. Strike them both at the same time.
Okay, so listen again for what's going on here. That pulsing sound that you hear.
Can you hear the throbbing?
That's what beats are. Beats are that pulsing, throbbing sound that you're hearing there. So explain what beats are and what causes them. So first of all, they're a pulsing sound created when two frequencies are nearly identical but not the same. Okay? So, it's what happens when the frequencies are almost the same but not exactly the same. Okay? And the fact that they're slightly different is going to make them so they make that throbbing sound. And the reason is interference. What's happening is they're sometimes doing constructive interference, which makes them louder, and then they're doing destructive interference, which makes them quieter. And then constructive, destructive, constructive, destructive. That's what that pulsing sound is that you're hearing. You're hearing it changing between constructive interference and destructive interference. And a good example of this is out of tune instruments. If you have ever played in a band, it could be a brass band, a string band, a rock band, if you've ever played with a group of instruments before and they're not in tune, you hear this really awful kind of pulsing, vibrating, throbbing sound. And that's what beats are. Beats are that pulsing sound, and it's created because they're interfering with each other, but they're not doing only constructive, which would make it louder. They're not doing only destructive, which will make it quieter. They're doing a combination of both. All right. Questions there? All right. If you want, you can go ahead and put that away or off to the side, whichever is easier for you. We're going to jump into notes 2 here in just a few minutes. But I'll give you a chance to chill just for a second while we get ready for the next part.